Okay, number 4, guys. Number 4. What do we have? So the curve C has equation y equals 4x root x, plus 48 over root x minus root 8. They're going all in here. Find simplifying each term, the first two derivatives. So what I would do before even doing this is firstly rewrite this equation in a nice way. Basically, we can say y equals, and then change, realizing that root x is the same as x to the power half. Just start combining and put everything on the baseline. So we can say x times x to the power half, you just add the powers, you get x to the power 1.5 or 3 over 2. Doesn't quite matter what you use really. Next, the second one, if it's 1 over root x, remember root x is x to the power half, and it's because 1 over will be negative half, so it'll be plus 48 to the power x minus a half, and then minus root 8. And remember, this is just a constant, so try not to get confused with this root. Okay, so now we just differentiate the first two terms. So we can say dy over dx for part A is going to be, so drop 3 over 2 down, so it'll be 4 times 3 over 2, so it's just going to be 6x, and then subtract the power, you're going to get half. And then the next one, yeah, you drop the minus half down, so 48 times minus half will give us minus 24, and subtract the power by 1, you get minus 3 over 2. Okay, not bad. Now, as for the second one, the second derivative, just differentiate again. So d2y over dx squared, differentiate this, drop the half, you get 3x, and it becomes minus 1, you get negative half. Drop the minus 3 over 2, so in your calculator, minus 3 over 2 times 24 will give us a positive 36. Subtract the power by 1, minus 5 over 2. Or use a decimal system, whatever works for you guys. Alright, so that's this bit then. This bit done. Now part B. Use part A to find the exact coordinates of the stationary point of C. When something is stationary or has a turning point, this means that the gradient is flat, meaning dy over dx is 0. So you basically made the first equation and set it to 0. So we can say, okay, so when dy dx is 0, we're going to get 6x to the power half minus 24x to the power minus 3 over 2, and it's going to equal 0. Okay. Now, yeah, so now we just have to realistically just solve this. So what you could do is firstly, just make it easy, convert everything back to its original form. So we're going to have, let's see, this would be 6 times root x minus, and then since it's a negative, reciprocate, so it'll be 24 over, and then this is root x to the power 3 equals 0. Okay, so what can we do? So let's go ahead and clear the fraction. So let's times root x cubed across here. Times that across, you're going to get 6 root x to the power 4, but that's really wonky, which is the same as x squared, by the way. So this is 6x squared. That becomes minus 24, and then we get 0. And that was easy. So now solving this directly, adding 24 across and then dividing 6, you should get 4. Square rooting both sides, you get plus minus 2. And just double checking what they want. They want the exact coordinates of stationary point C. We also know that the x coordinates are greater than 0, so it's positive. So the actual solution will therefore be 2. Okay, that's the x value. And yeah, now to get y, just put that back into the y equation, which is over here. So it'll be 4, God, this is going to be crazy. So it'll be y equals 4 times 2 root 2 plus 48 over root 2 minus root 8. Whoa, that's intense. And then putting on your calculator, you'll get exactly 30 root 2. So the coordinates in part B would be 2 and 30 root 2. Nice. Let's keep going. So part C, determine whether the stationary point of C is a maximum or a minimum, given a reason for your answer. Now, to determine this one, maximum minimum means firstly, you set the first derivative to 0 and then you obtain a certain x value. Now we want to check whether x equals 2 or plus or minus 2 is either maximum or minimum. Maximum indicates that if it had a turning point, like, I don't know, this would be the highest point and this would be the minimum point, theoretically speaking, yeah? So pretty much to determine whether it's max or min, use the second derivative, plug in your x values and see if it's the answer is positive or negative. Let's check, yeah? So part C. So using d2y over dx squared and testing a current x value at point C. Remember, we're using the coordinate of point C. So it's going to be using at x equals 2. What do we have? Plug it into the second derivative equation. So you get 3 times 2 to the power negative half plus 36 times 2 to the power minus 42. And you should get an answer which is actually positive, which is bigger than 0. So if something's bigger than 0, we say it's a minimum. Yeah, if it's less than 0, it will be a maximum.